So now we're going to turn our attention to different types of Java threads. And it turns out that there are two primary types of threads, user threads and so-called daemon threads. So let's talk about these two different types of threads. And we'll use a kind of a running example to make the thing work. The Java virtual machine, or the Java execution environment, when it starts up, will contain a single user thread. And this is typically known as the main thread. So there's one thread that's always going to be running when a process starts that runs the Java execution environment, like the Java virtual machine. Now, what'll happen when a thread exits will differ depending on whether a thread is a user thread or a daemon thread. And it's very important to understand the distinction between these two different types of threads. The life cycle of a user thread, which is a thread that's created, say, initially from the main thread or by some other thread created by the main thread, the life cycle of a user thread can actually outlive the main thread. So if, for example, the main thread starts up, spawns a bunch of user threads, and then it goes ahead and will go away, then as long as there's a user thread that's still running, then the process will continue to run. So even though the main thread goes away, like it falls off the end of main, it returns off the end of main, as long as it doesn't throw an exception that's not caught, then we'll allow the process to keep running. However, when all the user threads go away, and of course, if there's just the main thread, when the main thread goes away, if that's the only user thread that's available, then all the daemon threads are automatically terminated. So it's very important to understand what type of thread you have to determine what happens when that thread exits. So main rule is user threads can outlive main, but daemon threads can't outlive user threads, including main. So when all user threads have exited, returned, for example, and the only threads that are remaining are all daemon threads, then the virtual machine and the Java execution environment and so on will automatically shut everything down and will terminate the daemon threads. So these daemon threads are typically used for various supporting operation roles. For example, there's a timer class that can be used to run operations based on the passage of time, and that spawns a daemon thread. There's also something called the common fork join pool, and the common fork join pool uses daemon threads. So what that means is that when the user threads have all gone away, then the threads that make up the common fork join pool, the thread or threads that make up the timer package, they will automatically exit. So they don't keep the process running when everything else that's a user thread has disappeared. So let's go ahead and take a look at some examples of user threads versus daemon threads. And this will give us a chance to kind of walk through some code. So the first example we're going to look at is in my GitHub repository. It's called user or daemon thread. And it's going to be used to demonstrate the difference between a user thread and a daemon thread. And I'll just quickly walk through at a high level what the program's about, and then we'll go take a look at the code. This particular example extends the thread class. That's the way it provides the computation, generates a bunch of random numbers, and then computes their greatest common divisor. And if you launch it with no command line parameters, the main thread creates a user thread, and that user thread can outlive the main thread. So if the main thread goes away, the user thread can still continue to run till it's done computing the greatest common divisors. However, if you launch it with command line parameters, it creates a daemon thread. And as we'll see, when the main thread exits, the daemon thread will also exit. So let's go ahead and switch over and we'll see how this actually works in practice. So here is my project file for IntelliJ, which is containing the user or daemon thread project. And this is going to demonstrate the difference between a user thread and the daemon thread. So you can see that we've got a string that keeps track of the thread type, and we just use that for debugging purposes. We're going to run 100 million iterations, which is going to run for a while, obviously. We have a constructor called user or daemon thread, which is the name of the class. And that takes a Boolean that says what kind of thread to make. And if the Boolean parameter is daemon thread, we set the thread to be a daemon by calling the set daemon method that's part of the thread interface. So we get access to it because we inherit or extend from thread. And then we just set the string to be either daemon or user just for debugging. Here's the actual computations we do here. This is the compute GCD method. And as you can see, it just goes ahead and computes the greatest common divisor, which is the largest positive integer that divides two integers without a remainder. And you can see here, this is just a very simple Euclid algorithm using recursion. Here's the run hook method. This hook method, of course, is what's going to be called when the thread is started. And you can see what it does is it prints some diagnostic information indicating what kind of thread it is. It makes a new random number generator. And then it iterates for 100 million times and computes two random numbers. And then every 10 million iterations, it computes their GCD and prints the results of that. So this is basically just a way to burn some CPU cycles in the background to make the test interesting. Here's the main program. If the command line has a command line parameter is passed, it's a daemon thread, otherwise it's a user thread. And then we go ahead and make the user or daemon thread with the parameter passed in, the Boolean, to determine what kind of thread to do. We then start the thread, and that'll have that background thread do the computations of the GCD, the many hundreds of millions of times and so on. And then we have the main thread sleep for 1 second and then exit. So let's go ahead and run this program, and you can see what it does. So what it's going to do is it's going to go ahead and start up. And you can see here that the thread is going to run a bunch of different times, and it'll keep running. And if you take a look, you can see how we ran the program. Take a look and see what the parameters. You can see we passed one parameter to it. So in this case, this is running a daemon thread. So you can see when the main program exited, the daemon thread was terminated and stopped running. Let's go over here now and clear out this parameter. And now let's rerun the test. So now this will run as a user thread. You can see the diagnostics indicate it's a user thread now, not a daemon thread. And notice how when we left the main method, that the user thread continued to run in the background. Whereas before, it didn't do that. It terminated as soon as the main thread exited. So that's just kind of illustrating the difference between a user thread and a daemon thread. And that particular example was set up in such a way whereby we had the user or daemon thread class explicitly extend the thread class. So that's one way of doing this. What I'm going to do now is show you an alternative way of demonstrating user and daemon threads. This is example 2. This particular example is going to have the same computations that we did before with a user thread and or a daemon thread. But in this case, we're going to demonstrate how we're going to have a class called GCD Runnable that implements the runnable interface instead of extending the thread interface. And I'll talk about why we need to do that, and you'll see how it works. So now we're taking a look at this alternative way of being able to run user and daemon threads. And unlike the first example where we extended from the thread class, in this example, we're going to implement the runnable class. And this will demonstrate another way of being able to have threading models programmed using Java threads. This will also, again, demonstrate the difference between user threads and daemon threads. But this is really not illustrating that as much as it's showing the difference between implementing runnable versus extending thread. So here's the test program. It's very similar to what we had before. The main difference is, in this case, instead of extending thread and having a class called user or daemon thread, we're going to have a GCD runnable variable called runnable command. And we're going to go ahead and allocate a new instance of GCD runnable, which will either be a user or a daemon. And you'll take a look at that in a second, show you how that works. We then go ahead and create a new thread, passing in the runnable command. And then if we're running this as a daemon, we set that new thread to be a daemon. Otherwise, we set it, or we don't set it, which makes it a user thread. We then start that thread, and then we do exactly what we did before. We have the main thread sleep for a second while the background thread does its thing. Let's go take a look at GCD Runnable, and this is really the interesting part. So you'll notice here that instead of extending thread, instead we're going to implement runnable, which is the alternative way of giving the behavior you want to run in a thread. And just for kicks, just to demonstrate that by not extending thread, it allows us to extend something else. In this case, we're going to extend the random class just for fun, just to inherit random number generation capabilities. Here's the implementation. This looks very much like we did before. We're going to stash away the type of the thread as a debugging tool here in the thread type field. Going to run 100 million iterations. The GCD algorithm is exactly the same as before. It's a recursive Euclid algorithm. Here's the run hook method. This looks also very much like we did before. It iterates for 100 million times, calling next int, and it calls next int because it inherits from random. So it inherits the next int method from random. And as before, every 10 million iterations, it's going to compute the GCD and print the results out. So you can see that that's just the logic. We're not extending thread, we're just implementing runnable. And so as a consequence, for this particular example, you can see here, it's going to start out with a parameter passed in, could be anything we want, we just need a parameter. So this means it's going to run as a daemon thread, and therefore when it runs and the main thread exits, the daemon thread gets shut down. And as before, if we come over here and we edit this to remove that parameter and rerun the test, now it's going to run this as a user thread. And you can see again, when the main thread exits, the user thread still continues to run. Okay, so that's just kind of illustrating the differences between these two approaches. And the main point of all this was to show user thread versus daemon thread, as well as to show the difference between extending the thread class versus implementing the runnable class.